Okay, number one says your goal is to determine whether there is an association between which store shoppers shopped at and whether they made a list or not. Be sure to address at least the following and explain all your answers. What is the independent and dependent variable? So the dependent variable would be the list or having no list, and then the independent variable would be the store, because since the store has no like impact at all, like that would be the independent variable. And then B says, what are the conditional proportions you will use to determine whether there's an association between these two variables? So you would compare the number of people who made a list to the total number of people observed at store A, store B, and store C. So for store A, you would do 77 divided by 96, and that will give you the 80.2%. 74 divided by 96, which will give you 77.1%. And then you're going to do 68 divided by 96, and that will give you 70.8% for store C. And so I said 80.2% of shoppers at store A used a list, while the remaining 19.8% did not, because that's just the rest of the percentage. And then 77.1% of shoppers at store B used the list, and 70.8% of shoppers at store C used the list. So this one was definitely, store A was definitely the most popular place to have a list. And then for question C, it says, compare the proportions using either differences or ratios of proportions, explaining which you chose in your calculations. So I chose comparing the people at store A who had a list to the people at store C who had a list, and which one was like bigger, I guess. So first I did the obviously 77 divided by 96 and 68 divided by 96, and we don't need store B anymore since we're not comparing it. And then I plugged it into the proportion. So first I decided my P1 would be 0.802 and my P2 would be 0.708, right? And then I plugged those into the equation. So first I did 0.802 in parentheses, and that's going to be multiplied by 1 minus 0.802 divided by the total, which was 96. And that's how I wrote that. And then once I solved that, I got 0.0016. And then I am going to have to do the same for store C. So that's going to be 0.708, and then 1 minus 0.708 divided by the total number of shoppers observed at that store, and that's going to give you 0.0021. And then I'm going to go add these two numbers together and then take the square root. So once I added them together, it was 0.0037, and the square root of that equals 0.0608. And that's not a huge difference, so it seems like there's not a big difference between them. But then for the question D, it says specifically state whether you believe there is an association between the variables and explain why. I said I didn't think there was an association between the people at store A compared to the people at store C, since they're super close statistics, and the answer I got was super tiny, so that means they're super close like together already, so I don't think there's an association between the variables. For question 2, it says your goal is to determine the strength of the association between the two variables displayed in the scatter plot, and then to use the regression line to make predictions. So the scatter plot is of data on 62 male athletes, and is talking about correlation. So for question A, it says, is there a correlation between bench press repetitions until fatigue and maximum bench press weight for male athletes? If so, how strong is it? How do you know? So the first thing I looked at was the correlation coefficient R, and it says R equals 0.907. And we talked about in class, like, the closer that is to 1, like, the stronger it is. So that's already a really strong line and correlation. Um, and it's almost like a perfect correlation because it's almost like a perfect straight 1 because it's only like 0.1% or 0.1 away from being a 1. And then for question 2 or question B, it says use the regression line to predict what the maximum bench press weight would be for a male athlete who can do 32 repetitions until fatigue. So first I went on the x-axis all the way over to 32, and then I went up until the regression line. And I was looking at the regression line, and it looked like it almost fell perfectly on the regression line at 300 kilograms. So I said, my prediction is that it would be 300 kilograms of bench press weight for question B. And then for C, it says, suppose that you observe that an athlete, a male athlete who can bench press 32 repetitions until fatigue can bench press 200 pounds. What is the residual for this observation? And I was kind of confused why it said pounds because the rest is in kilograms, so I assumed it meant kilograms because whenever I convert pounds to kilograms, it gives me like 90, and I'm like, that's really, really tiny. And then it asked for the residual of this observation. So what I did was I did my predicted, which was 300, or my measured rather. My measured was 300, and my predicted is 200, and I got 100 as my residual, which is a really big difference. And then it says for D, based on your response to C, does your regression line give you an overestimate or an underestimate? And I said that it gives you an overestimate, like the regression line does, since whenever we looked at question C, it was so much lower than the other points that were on the graph. So maybe that's like an outlier. Just like there's another point on the graph at 20 on the x-axis, and it's way up there by 348-ish on the y-axis, and that one seems really, really not on the regression line at all, just like this point was. So I think that one is just an the regression line is just an overestimate, and that point seems to just be really small in comparison, so maybe it's an outlier.